Step outside on a freezing day, and your skin reacts instantly. Tiny raised bumps ripple across your arms, and your body hair stands straight up. Medically, this is known as the pilomotor reflex, or cutis anserina. You can't control it, and you can't stop it. Your autonomic nervous system simply hijacks your skin. But as a mechanism for staying warm, this reflex makes no physical sense for us. Humans shed our thick, insulating coats of fur millions of years ago. Without that thick fur, raising a few fine hairs does nothing to trap heat. It operates like an evolutionary ghost, a biological glitch firing off a command for hardware we no longer possess. To understand why our bodies force our skin into these bumps, we must travel beneath the surface and look at the actual wiring triggering them. Deep inside the dermis layer lies the sympathetic nervous system. This is your body's autonomic control center, built to handle immediate fight or flight responses. When the hypothalamus detects a temperature drop, it floods skin nerve junctions with adrenaline and norepinephrine. These chemicals bind to arrector pili muscles at the base of hair follicles. The muscle pulls the hair upright, forcing tissue to bulge outward into a distinct mound. This coordinated chain of chemical and mechanical events works flawlessly. It is ancient survival hardware, running exactly as it was programmed to. For our early hominid ancestors, this hardware was essential. In freezing weather, that reflex puffed their thick coats of fur outward, trapping a pocket of warm, insulating air right against their bodies. It also triggered when they spotted a predator. Standing all their hair on end made the animal look physically larger and much more intimidating to an attacker. Evolutionary biologists like Charles Darwin observed this exact trait across mammals. He documented our goosebumps as a direct physiological link to other animals, persisting long after we lost our fur. This document is a research paper analyzing how music induces chills. It highlights a biological paradox. Modern humans routinely activate this ancient fight-or-flight hardware during moments of intense emotional arousal, like listening to a powerful piece of music. Looking at this study on emotional piloerection, we see it correlates precisely with sympathetic nervous system activation. When a song has an unexpected shift in the volume or harmony, your autonomic system perceives it as a potential threat. It floods your skin with adrenaline before your brain can process that you are perfectly safe. Whether we are listening to a symphony or looking at a vast canyon, our nervous system responds to beauty by running its oldest survival software. It is easy to assume that goosebumps are simply a leftover reflex. But macking the skin down to the absolute cellular level reveals a hidden function. Researchers at Harvard University recently mapped the hair follicle at an ultra-high resolution and found an unexpected structural relationship. They identified a dual-component niche where the sympathetic nerve and arrector pili muscle work together. These nerve fibers don't only connect to the muscle. Supported by it, the nerves wrap tightly like a ribbon directly around the hair follicle's stem cells. The tiny muscle pulling your hair upright serves as a physical scaffold. It bridges the gap between your nervous system and your body's regenerative stem cells. A brief shiver gives you a short-term goosebump, but your body reacts differently when the cold doesn't go away. Under prolonged cold, the sympathetic nerve ramps up activity, releasing neurotransmitters directly into resting stem cells. These signals act as a command code. The stem cells wake up, multiply, and regenerate the follicle, growing a new hair shaft to insulate the body. The goosebump operates as a highly sophisticated environmental sensor. It acts as a direct communication line, telling your body exactly when it needs to regenerate its own tissue. It is a biological masterpiece, a mechanism that connects our ancient mammalian past to our modern emotional peaks and drives the ongoing cellular regeneration of our skin. If you want to uncover more of the hidden biology operating right under your skin, hit subscribe. We have a lot more mysteries to explore.